Let us discuss the basics of differentiation. If x to the power of n is the function and we are finding the derivative of this with respect to x, same variable here, then it is n into x to the power of n minus 1. For a different function, different derivatives will appear. This is most repeatedly used formula at very basic level. Let us work out with some examples. Example 1. I am taking x power 4. N value is 4 here. The derivative is 4 coming down. X 1 lesser power. That is n becomes n minus 1. 4 becomes 3. Let us work out with a negative power. X to the power of minus 3 suppose. It may also appear like 1 by x cube. If it is 1 by x cube, make it as x to the power of minus 3. Now that minus 3 will appear here. That same variable x will be there. Minus 3 minus 1. That becomes minus 4. And that can be written as minus 3 divided by x to the power of 4. Let us take a fraction for example. D by dx of x root x. Now first of all you make it as a single power of x, that is going to become 1 here, half here. So 1 plus half, that is 3 by 2. So x to the power of 3 by 2. Now the derivative I am writing here, but next step I will not write d by dx. As per this particular formula I will write the value of the derivative. So 3 by 2 comes down, x to the power of 3 by 2 minus 1, that is 1 and a half minus 1, that is half. So that will become x to the power of 1 by 2. X to the power of 1 by 2 is root x, as I have written here. That was x power 1 by 2. So finally it is how much now? 3 by 2 root x. Clear about different situations of this formula? Okay, fine. Clear? So the second most repeatedly used formula is d by dx of e to the power of x, that is equal to e to the power of x. If e to the power of 2x comes, then it is 2 into e to the power of x, but I am not arriving at that because that can be done using the chain rule. I will explain that chain rule. Using that chain rule we will do that one. So basically we are taking the variable only, just variable x. So derivative of e power x is e power x. And if it is e to the power of t and we are doing differentiation with respect to t, then it will be e power t again. But if it is x here and t here, what to do? Let us see that using the chain rule. That chain rule, you remind me if I forget. Chain rule I will tell in this basics. So we have a list of formulas. Derivative of sin x is cos x. Derivative of cos x is very good, minus sin x. And derivative of log x, it is equal to 1 by x. Very good. Now the list goes on continuing. You have a lot many functions, but most repeatedly used functions are this many. Some more are there, but I am skipping them. So shall we end up with this 5? What you need to understand, there are more number of functions. There are so many other functions in this list. So you copy down this list. We have finished a list of 5 formulas. Okay, what was that list? Formulas. That list was with 5 we have done, but still it goes on continuing, right? There are so many. So one level is the list of derivatives of standard functions. And second thing is rules of differentiation. In these rules of differentiation, you have the first one among them, that is, if f of x is one function of x, g of x is another function of x, we can also write any number of functions, but explaining only for 2, that can be extended for any number of functions. If a is multiplied to this, b is a constant multiplied, a is a constant multiplied to f of x, b is a constant multiplied to g of x. If plus comes here or minus comes here and we are finding the derivative, this f of x and this g of x may be any function from that list of standard functions, then we will separate this a constant outside and we will write the derivative of f of x, and if plus comes, plus will be there here, if minus comes, minus will appear here. So instead of writing two formulas separately for plus and minus, I have written compactly plus or minus. This constant b comes out of the differentiation process and we will be having d by dx of g of x. As a simple demonstration of this particular rule, this is called as sum rule. Shall I write it here? Sum rule. So if I have x square and if I have e to the power of x, if it is 3 times multiplied and it is 4 times multiplied and there is a subtraction, then the derivative of this function is as per this rule. Actually this function we cannot memorize in the list of functions. That list of functions should not be limitless. I mean unlimited function should not be there in the list. So we remember for some and we derive for some new functions using the rules. So what we will do, we will take the constant 3 outside. Okay, you tell it is 3 into d by dx of, very good, d by dx of x square minus 4 times of d by dx of e power x. This particular part will be available in the list. This particular part is available in the list. Okay. So what we do now? 2x for this one. This is already okay, mastered that concept, and e power x derivative is e power x, so it will be minus 4 e to the power of x. I can skip this one by writing 6x minus 4 e to the power of x. Now you can take 2 common also, you can write it. So you can write it as 2 times of 3x minus 2 e to the power of x. What is 2 times of 3x minus 2 e power x? It is the derivative of 3x square minus 4 e power x. Suppose if I have plus sin x, then one more term will come, plus d by dx of sin x, and cos x comes here, cos x comes here. So it is extendable to any number of functions. I have demonstrated only with 2 functions. In the simpler case, if it is not there, suppose, then d by dx of 3x square constant comes out, only 6x will appear. Got my point? Clear? Okay. Now let us see the next rule for differentiation, that is product rule. Suppose I have 2 functions, f of x and g of x. They are appearing in the form of a product. Then d by dx of this is equal to, why that rule has come I am not explaining, what is the rule I am saying now. So take the function f of x as it is, do the differentiation for the second function. Means one time we are doing differentiation for g, one time we will do differentiation for f keeping g as it is. So plus g of x into, any term can be written first, any term can be written next, no problem, d by dx of f of x. So one time we are doing differentiation for one other function, it is kept constant. Some people prefer to write this first, means d by dx of f of x into g of x, then this one. Anyway, there is no issue with that. Now let us practice this one with an example. If I have e to the power of x with the sin x, then what is the derivative of this one? I will first keep this e power x as it is. Wait, I will give you time afterwards. E power x into d by dx of sin x. Don't write cos x here because I am just writing d by dx of this one. Next term we will write cos x, next step, plus I will keep that sin x as it is, and then I will write d by dx of e power x. Later on, once you are okay with these concepts, you need not write this step, you can directly write the next step. What is this one now? e to the power of x into cos x plus sin x into e to the power of x. But better to write this step as e power x into sin x, because that may give the feeling that sin is for that both of them, x and e power x. So avoid writing that way, write e power x into sin x. Understood the point? And once the rule is understood, we can apply that rule for different f and g. I'll do one thing. Just I'll write simple functions. You tell me now d by dx of. Let us avoid these all detailed steps and write that directly. We have suppose x square e to the power of x. Then tell me in one step. First x square will be as it is and e power x will appear plus. Now e power x will be as it is and 2x will appear. So that will become 2x e to the power of x. If you want, you can write e power x common later on that one. I hope you understood, right? So how many rules we have seen till now? 2 rules, sum rule and product rule. Can you guess what will be the next rule? Quotient rule. F into g is over. F plus g is over. F minus g is also over. Subtraction, addition. That together will be called as sum rule. So now you expect f of x by g of x. That is quotient rule. It is a little bit lengthy one. So don't write now, I will give you time. If you have, listen, if you have two functions, one in the numerator, one in the denominator, what you do is, this denominator function you directly copy in the denominator, but square this one. Same g of x squared. Once you write this one, that g of x you continue here and that same g of x you write it here. So g of x whole square and then g of x. Once you wrote g of x, differentiation should be done to this f of x. So d by dx of this f of x. Once it is like this, the other thing should come, but there is a minus sign in between. So what should remain now? Here g of x is there. Here what will remain? F of x, and derivative will be for g of x. Keep in mind, you cannot write that term here and this term here because there is a minus. So which term should come in the beginning? If you write numerator first for the formula, you may have a confusion whether to start with f or whether to start with g. So I suggest you write the denominator first. And how to continue the denominator? This is in the denominator, so write it in the denominator. You write the square for this one, then continue that g of x. Then once you write g of x here, there is no confusion. D by dx of f of x will appear. The other one will appear here with a difference in between. Now we will take up the basic functions. You tell some function in the place of f of x. F of x, you tell some function. No, f of x is some function of x in 5x, okay, 5x, 8x. It will get cancelled and 5 by 8 will be a constant. Huh? Huh? 4, 3x. X will cancel 5, only it will be a constant. Or tell some other function. This is like x power n. 3, f. What is that f? Oh, so nice. You tell sin x, for example. You don't have direct cancellation like that function, you should tell it. E power x, that was possible. So instead of this, let us make it as e power x. Better, fine. If it is e power 2x, how to do? Chain rule. I said I'll tell it as per chain rule. First I am taking only just a variable. I am not doing anything to that variable. Straightforward variable I am using. Now, what is this one? Sin x. What is the derivative for this one? First I need to write the sin x in the denominator and I have to square this one. Then what I have to do? Sin x, without looking at that side, you just write it as sin x into d by dx. To save one step, I am not writing d by dx. I will directly write the derivative value. I will directly write the derivative value for this f of x, that is numerator function. 5 e power x is there. You can take 5 outside and write a very big bracket, but that is not required. What to do? You treat this 5 e power x as one function. So what is the derivative for 5 e power x? 5 is 5 as it is. E power x derivative is e power x as it is. Constant will be unaffected in the process of differentiation. Pure constant derivative is 0. But if it is there along with some function, it will be just along with that. Okay, finished. Next, minus. Now definitely this 5 e power x will appear as it is. And then we will write the derivative for sin x. Derivative for sin x is cos x. Very good. Cos x. That is equal to 5 e to the power of x common. Very good. Sin x minus cos x. Here, instead of writing this much long fraction, you can directly write that sign here. And if power is 2 here, that power you can write it in the short form notation sin square x. Yes? Okay. What we have done till now? I said a list of formulas. Second thing I said, rules of differentiation. What are the rules of differentiation discussed till now? Sum rule, product rule, quotient rule. Means addition, subtraction, multiplication, division, all the 4 are over. I discussed only for sin x, the derivative is cos x. But what happens in the case when we have 2x here for sin? What is the derivative of this one? Then it is cos 2x. It's like sin box. What is this like? Box. What is the derivative of sin box? That is cos box. But the box is different from this variable. So you have to take the derivative of this box. The derivative of this box is derivative of 2x. What is the derivative of 2x? 2 coming out, x to the power of 1. So 1 into x power 0, that is just 1. Simply speaking, derivative of all x with respect to x is 1 always. So it is 2. That 2 will be multiplied here. But instead of going this way, I will tell you the chain rule from which we are getting this one. Why we need to multiply that 2 here? That I am explaining using the concept of a chain rule. Chain. The most important of the rules out of that 3, out of that means including this one 4, out of this 4, this is the most important rule, chain rule. Now see here, suppose we have a function of t and we are doing the differentiation of this function of t with respect to x, and that t depends on x. What is the meaning of f of t? Function depending on t. Now function f is depending on t, that t is depending on x, means what? F is depending on x via, as we say, I am going from Hyderabad to Chennai via, you will tell middle place. In that same way, f is depending on t, t is depending on x. Therefore, f is depending on x. There may be a long chain. For example, f depends on t, t depends on u, u depends on v, v depends on x. Even then, f depends on, finally f depends on x. When f depends on x, then we can find the derivative of f with respect to x, because f is depending on x. Then what you do is, part wise you find the derivatives and you multiply. Derivative of f, one level, derivative of f with respect to t. F depends on t. So derivative of f with respect to t. then multiply with this level. I am going one by one now, just one level. Then derivative of t with respect to u, dt by du. Then I will multiply that derivative of u with respect to v. Then derivative of v with respect to x. In simple way, if you check it, this dt gets cancelled, this du gets cancelled, this dv gets cancelled, and we are left over with only dx and this df, that is df by dx. You can have a long chain, that is why we call it as a chain rule. But generally, we have only one variable. Let me not say generally, it can be any number of variables. For example, I am giving that f depends on t depends on x, then f however depends on x. What is derivative for this f of t with respect to x? Then first of all, do the differentiation of this f with respect to t. Means it is f of t, you think it is t here, like that you can do the differentiation. And then means I am talking about this only, derivative of f with respect to t, and then multiply the derivative of t with respect to x. Is this point clear? The other way you can feel like this, f of t, I want derivative with respect to x, so I will do like this, d by dt of f of t into this t derivative with respect to x. Instead of writing this full f of t, we are writing in short df by dt. Its full form, it's like this. So if this is understood, then I'll give an example like this. I have sine of x square. Then carefully understand, it's so simple. I am taking this x square, I want to differentiate with respect to x. Then take this x square as t. Means t is equal to, just the other way I am writing like this. Now f is depending on t. This complete is like f of t. Or I will write it as sine of t. By taking x square as a t, this becomes a sine t. I am doing the differentiation of this sine t with respect to x. So this is f of t. What should I do then? What is the rule? What is the rule? I missed writing this one. Actually I rubbed that one. Oh, very good. df by dt into dt by dx. So f depends on t. Directly do the differentiation of f with respect to t. It is in sine t, and we are doing the differentiation with respect to t itself. Yeah. Into, come on, dt by dx. I said earlier, if it is sin x and we are having d by dx, that is cos x. If it is t and t here, that will be cos t. So it is cos t. That into derivative of t with respect to x. What is the derivative of t with respect to x? It is just 2x. Now this detail I have given, but we can do that problem in a very simple way in one line. As a first example, I am saying how the chain rule is working. So what is cos t? T is nothing but x square. So this will become cos of x square. That 2x you write it in the beginning. So it is 2x into cos x square. So what is 2x into cos x square? It is the derivative of sine of x square. Copy this. Copy as it is. Now we need not go for all these detailed steps. There is only one line answer for this one. Let us do in that way. But these are the background points which I said you. Now I have sine of x square. I want the derivative with respect to x. If it is just x, it will be cos x. but it is x square. So x square is going to become another variable. It is not exactly like x, it is the square of x. So it is another variable. So this complete variable will come as it is with the cos. So this is one step over. We have treated like t, so that t has come. Now we enter into that variable. What is that variable? X square. Forget about this sign because it is handled with cos. That's over. Now we will write the derivative for this x square, that is 2x. Now again derivative of this 2x will not be written because x square derivative with respect to x is 2x only. The chain will not continue again. X square derivative with respect to x is 2x. Now let us see further more different examples now. E to the power of sine of x plus 3 or x square plus 3x. Now what happens in this case? I want the differentiation or derivative, better not differentiation, that is a process. So the derivative of this function. So first you feel as if this something is a box. So e to the power of something is e to the power of that same thing. So what happens now? That will become sine of x square plus 3x. So we are least bothered what is written there, that will copy. Now this e is handled. So we will go into that part which we have neglected. We are now focusing on that part. So into. Now you are looking at this part. So again make this as silent. It is looking like sine something. So it will be cos something. That something is x square plus 3x. Now we have handled that sign. We are entering into the next variable x square plus 3x. Now we will multiply the derivative of that. Again the sum rule comes now. There are two functions and both of them are there in the list as per the formula of x power n. So it is 2x plus 3. I hope you understood. Let us see some more examples of chain rule. I have sine of log of cos of e to the power of 2x square plus 4. This much difficult function may not come at any time to you, but we are just handling this. 1, 2, 3. 3 openings, 3 closings, right? So wait for some time. You write afterwards. At a glance, in the outermost it is looking like sine something, no? So what do you do? Cos something. Sine derivative is cos. So you write it as a cos. Copy this as it is. So it is log of cos of e to the power of 2x square plus 4. Following 1, 2, 3, 1, 2, 3. Here, wait, I have to write dy dx. I am taking the derivative of this one. Now derivative of this one is sine became cos and everything is copied as it is. Into what? Into. We have to go on multiplying now. So what comes? I'll write into here better, looking like this now. So sine is handled. Now we will come to log. Log of something is 1 by that something. So 1 by, because there is no much space available there, I am writing here. Actually it should come there, it looks beautiful, right? So 1 by what now? Come on. Cos of, very good, cos of e to the power of 2x square plus 4. Finished. Now into. We need to handle cos of this one. That becomes minus sign. So minus sign of e to the power of 2x square plus 4. Finished. Into. Again. Into. Sign is that particular cos is handled, it has become minus sign. Now we are left over with e to the power of 2x square plus 4. That chain is getting continued. Now what? E to the power of something is e to the power of something, right? So it is e to the power of 2x square plus 4 into. Now e is also handled. We are left over with 2x square plus 4. So very good, 4x plus 0. That is just 4x. Again you don't continue with 4x into 4 because x is 2x square derivative itself fully, completely the derivative is 4x. Again that chain will not continue. Okay.